Consider the resistance in a wire. Our V question says, does adding wires in series or in parallel affect the overall resistance of the circuit? Please notice that in circuit A, we have 2 long bulbs in a closed loop with a 2-cell battery pack and a compass. In circuit B, we're going to add additional wires between the 2 bulbs and see how the magnitude of compass deflection and the bulb brightness might be affected. In circuit C, instead of adding wires in series like circuit B, we're going to add wires in parallel, which would be taking a wire, a wire that we're not currently using, and attaching it to one socket clip across bulb 2, and then put the other end of the same wire on the far socket clip of the same socket. So we're putting a wire around or across bulb 2 and seeing how that would affect bulb brightness and compass deflection. Again, we want to figure out how does adding wires in series or in parallel affect the overall resistance of the circuit. It's very important to make the 4 predictions down the left-hand side before beginning. Once you've made your predictions, you're going to start with a 2-cell battery pack and 2 long bulbs in a loop. And you go ahead and hook that on there, and the bulb should be lit. Now, before we move on, I want to put the camera up close on the compass deflection on this, because the magnitude of compass deflection on this is not huge. Right now the bulbs are off and the wire is disconnected from the battery pack. On the count of 3, I'll attach the wire to the battery pack so you can check out the compass deflection. 1, 2, 3. Notice that the compass needle did move, but not very far. It's only about a 3 or 4 degree compass deflection. I'm going to remove the wire from the battery pack on the count of 3, and you can watch that compass needle resettle. 1, 2, 3. I'm going to go ahead and reattach that wire, but then pull the camera out further from the circuit so you can notice that the bulbs are also not very bright. They are long bulbs. Next up, we're going to go from circuit A to circuit B. We're going to attach these 3 extra wires between the bulbs in socket 1 and 2. To do that, I'm going to go ahead and connect this red wire to the yellow wire. I'm going to take the other end of my 3 wires and hook it onto the same socket clip on there. And the lights blinked a little bit, and that's not because I put the wire on there. So I'm going to try to hook it on there again. And notice we connected that there. As I remove the yellow wire, now we have doubled the number of wires in our loop. The compass deflection is still at 3 to 4 degrees, and the bulb brightness is still dim. There has been no change in the bulb brightness. I'm going to go ahead and remove the 3 extra wires from between the 2 bulbs. To do that, I'm going to attach the yellow wire to the socket clip and just basically go in reverse order from before. Remove the far end of those 3 extra wires, and now remove the red end, and notice the bulbs didn't blink at all, and there's been no change in compass deflection. So with no change in the compass deflection, what does that tell you about the flow rate when we added or took wires out of our series? If there was no change in compass deflection and no change in flow rate, how did adding wires to our series affect the resistance of that loop? Next up, we're going to add a wire in parallel across the second bulb. To do that, I've taken 1 wire, it happens to be green, and I'm going to attach one end of the wire to the clip before bulb 2 and the other end of the same wire to the clip after bulb 2. 1, 2, 3. Notice when I've done that, the wire that I hooked up in parallel across bulb 2 became unlit, while bulb 1 became brighter. Also, our magnitude of compass deflection has increased. It went from about 3 or 4 degrees clockwise to about 6 to 8 degrees clockwise. When I remove this wire we've hooked up in parallel, you'll notice the drop in compass deflection. 1, 2, 3. And you notice that it just resettled there. So when we added a wire in parallel across one of the bulbs, the compass deflection increased, which means the flow rate increased. If the flow rate increased, what happened to the resistance when we added this wire in parallel across bulb 2? Why did that happen? Well, when we add that second wire, we know that a wire has little to no resistance. So the charge, instead of having to go through the skinny filament of bulb 2, can now rush through the thick wire from the wire we hooked up in parallel across bulb 2. So it almost is going to have the same resistance as though we just had one long bulb in the loop. One more thing, two more things before we go today. Number one, I'm going to go ahead and charge a capacitor. And how will we know when the capacitor is complete discharging? Well, we always said when the bulbs became unlit, but even a more reliable way to look at it is to see when the compass deflection returns to 0. Now that the compass, or the capacitor, is fully charged, I'm going to go ahead and disconnect the bulbs out of our loop. And we're going to try to discharge this capacitor by tapping the ends of these wires together. If we don't have any bulbs or no resistors in the loop, how many taps of the wires, if I'm going like boom, 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 how many taps will it take us to discharge the capacitor? How could we even know? Well, if we watch compass deflection, let's count how many taps it takes. 1, 2, 3, 1. There's one tap. And on the second tap, we had no deflection. So it took only one tap of wires to discharge a capacitor, all right, or to reset a capacitor. So again, it looks like wires have little to no resistance. One extra question we could ask, we'll go ahead and hook this up like it's a charging loop again. So I'm going to hook the capacitor in them. The bulbs were lit temporarily. They're no longer lit. What would happen if I were to take an extra wire and place it across the terminals of this capacitor? So I have just an extra wire. If I place it across the terminals of the capacitor, what would we see happen here? Secondly, what will happen when I remove those wires from our setup? I'm going to turn the lights out to do this so that you guys get full view. So when I connect the ends of the wires, both ends of one wire to the capacitor, oh, I don't have the second bulb in the loop. Duh. All right. So, 1, 2, let's go ahead and now we'll give this a shot. If we hook on both ends of one wire to the capacitor, we now have a closed loop and the bulbs are now lit. When I remove the wire from the capacitor, what would we expect to see? Will the bulbs be lit or unlit or something different? 1, 2, 3. The bulbs did not go out immediately because when I removed the wires, it not only opened the loop, but what else happened when I had both ends of the wire on the terminals of the capacitor? The capacitor can reset. When I remove the wires, we now have a reset capacitor, which can now charge as the bulbs dim out. I hope that helps.